First one, I'm asking you to multiply. When we multiply rationals, what do we have to do, the tops and the bottoms? GCF, difference of squares. All the numerators, all the denominators. And we're going to keep practicing because you're going to have a cumulative after the next one. You have a cumulative test on the first 4 units. Okay? It's going to be a midterm. All right. So, we have x squared minus 4x. So we can take a x out, and we're left with x minus 4. The bottom is a what? Difference of squares. So we get x minus 4, x plus 4. Times top right, what can I take out? 5. Left with 3x plus 1. And then on the bottom I can take out an x, and I'm left with 3x plus 1. Now before I go to cancel, I have to make sure I do what? State NPVs. So I have 4, negative 4, 0, and a third. X can't equal plus or minus 4, 0, and negative a third. Then, because it's multiplication, I can go straight, all numerators over all denominators. Those cancel, those cancel, those cancel, and your answer should be 5 over x plus 4. X can't equal plus or minus 4, 0, and negative a third. How'd you do? Good? Then we went to some fundamental counting principle questions. And then we went to Venn diagram at the end. So a new restaurant has opened and they offer lunch combos for $5. That's pretty amazing if that were true. Make sure you're not on your phones. With the meal, you get 1 sandwich, 1 side, and 1 drink. And I told you that if you get 1 of each, we can do blanks. We agree? If we want to take more than 1 of each, we can't do blanks. Correct? We haven't learned how to do that yet, so obviously you can only take 1 of each. Now the meal choices are below, but the drink part of the board was smudged off. So we have 1 sandwich and 1 side and 1 drink. So the number of sandwiches, 1, 2, 3. Number of sides, 1, 2, 3. Number of drinks, and now it says how many different drinks were offered if there were 18 different combos. So this would have to equal 18, right? We don't know this one. So that's 9x equals 18. So what would x have to be in order for this to be true? 2, right? 9 times what is 18? 2. So how many different drinks were offered? There were 2 different drinks offered. Then the next one says a multiple choice test has 10 questions. So if there's 10 questions, we have 10 blanks. Number 1 and number 2 and number 3 and number 4 and number 5 and number 6 and number 7, number 8, number 9, number 10. And each of them has 4 answers. So this one's not a real hard one, right? It's going to be 4 in each blank. Remember I told you I could give you some of them, like number 1 is A, number 2 is B, number 3 is A, and then you have 1, 1, 1, and then 4, 4, 4, 4, 4. That's how they could change it. But these are all 4s. So some people decided to do 4 10 times. But we could have written this as what? Equals 4 to the power of 10. Because 4 10 times means 4 to the power of 10. 10 different models of cars are parked side by side. How many ways can they park so that 5 blue cars are together? Do I care what the rest of the colors are? Nope. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I want to park the 5 blue together. Oops. So I have 5 blue together. So I have 5 options for this one, then I leave a car. 4 options for this one, 3, 2, 1. How many cards do I have left in different colors? 5. So I go 5, 4, 3, 2, 1. Make sure you have the multiplication symbols, the dots. If you don't have them, go put them. It's going to be a real ugly test if you don't actually show your work with multiplication dots, right? And it's just a really large number. Now, if I said blue cards together at the front, I'd be done, right? So you have to read. Sometimes people read blue cards together and they move them always all the time and get the answer. Remember, if it said blue cards together at the front, or if they were at the back, this would be the answer. I'd be done. So you have to read thoroughly what it's asking you for. This one, however, says blue cards together. It doesn't say at the front or at the back. So we have to be able to move them, correct? It is always one more than this number. Remember I told you that? Because it'll always become 6, then 5, 4, 3, 2, 1, 6 factorial. If you forget, though, it's 1, then they could go here 2, or here 3, or here 4, or here 5, or here 6. So we're going to multiply by 6. So remember, these numbers get me 5 factorial. And then because I always multiply by 1 more than this number, I can go 6 times 5 times 4 times 3 times 2 times 1, which is 6 factorial. Did anyone get 5 factorial, 6 factorial as an answer? Type it in. What it would be. How much is it? What? I feel like you're whispering. I can. No?
It's 86,000.
86,400. The next one is the one that's done incorrect, but hopefully by the time test comes, you just pro at it. So this one says, how many ways can they park so that the 2 yellow cars are not together? Remember, what did we do when it was not together? We did total, no restrictions. So that's all the ways I could park the cars completely, no restrictions, right? And then what did I subtract off? The yellow, 2 yellow cars, what? Instead of not together, I do together. And then what's left over? The 2 yellow cars. Not together. So, total no restrictions is literally I have 10 cars, 10 factorial. It would be I have 10 blanks, and then I go 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which is 10 factorial, right? And that's all the maximum ways I could rearrange these cars, no restrictions. And then I have to subtract off the 2 yellow cars together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hook these 2 together. 2, then 1, then 8, 7, 6, 5, 4, 3, 2, 1. And what do I have to multiply this by? 1 more than the hook together number. 1 after the hook together number, which is 8. So this is going to be, I'm going to multiply it by. What number am I going to multiply it by? 9. I really hope you're choosing not to answer and that you actually understand it, because it's 1 more than this number. This number is an 8. So you will multiply by 9. This number was a 5. You multiply by 6. So we get 10 factorial minus 2 factorial, or just 2, because 2 times 1 is 2, times 9, 8, 7, 6, 5, 4, 3, 2, 1, blast off. So 9 factorial. Everyone's typing it into your calculator, because I guarantee you most of you did not have this right. So therefore you did not type it into your calculator. Type it in. By the test, if people practice it enough, everyone gets this right. At the beginning, you forget. It's okay. That's why we practice. You're subtracting 2 times 9 factorial. You're not subtracting 2. It wants 2 yellow cars together. So you hook 2 cars together, which is 2 times 1. 2 times 1 is 2. And then 9 times 8 times 7, 6, 5, 4, 3, 2, 1 is 9 factorial. So it's just 2 times 9 factorial. This is total no restrictions. This is all the ways I can rearrange the cars. You take all the ways you rearrange the cars, you subtract off all the ways the yellows are together, and then what's left over are the yellows not together. Because they're opposites of each other. We did this last week where I said, what's the fastest way to figure out how many people are in this class or in this school but not in this class? The fastest way would be to take all the total people in the school and subtract off people in this class, and what's left over are the people not in this class. So if you want to do not yellow together, you can't, trying to do it in cases isn't going to be pretty, because then yellow would be in first and third spot, figured out, and then it would be in like first and fourth, first and fifth, first and sixth, first and seventh, first and eighth, first and ninth, first and 10th, then second and fourth, second and fifth, second, like that's a lot of cases. I would not hazard that to be the fastest way. You're probably going to miss a few thousand. So the fastest way to find out when the yellows are not together is to take all the total ways I can rearrange the cars without any restrictions, which is 10 factorial. Because I have 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And then I subtract off all the ways the yellows can be together. Then I'm taking all the total cases, subtracting all the yellows together, and then what's left over, the yellows not together. So total number of ways I can rearrange cars minus the ways the yellows can be together, because opposite of yellows together is not together. So yellows together and not together should equal all the ways I can rearrange the cars. So if I want to find not together, I'm always going to do total no restrictions, all the ways I can rearrange the cars, subtract off the yellows together, and then left over will be the yellows not together. Which is what answer? I hope people have punched in by now. I refuse to open my calculator, so I'll just stand and wait it out. I put my calculator over there so that I don't actually give the answers.
It's a big number, and I don't want to see it.
You can just read it. Just give me the numbers.
9, 0, 30, 40.
We start from the back and we put little commas. This is a 2, and it's in the millions. This is the number 903, and it's in the thousands. And this is the number 40, and it's nowhere, so we just write 40. So we'd say 2,903,040. If it's stopping you from giving me a number because you're worried you're going to say it wrong, then say 2903040. I don't really care. I'm not marking you on your placeholders and place values. I just want an answer. So you can just say the number in numbers. I don't really care. I won't judge. All right. So, number 5. Using all the letters in the word sparkle. Does sparkle have any doubling or tripling letters? After today, we're going to have to look for that because we're going to have doubling, tripling letters today. I've always given you words that don't have repeating letters until today. Okay? So sparkle, S-P-A-R-K-L-E. It has 7 letters. I'm going to try again. S-P-A-R-K-L-E. It has 7 letters. I double check because so many people get questions wrong because they'll put 6 or 8 by an oopsie, and that would really suck. Okay, so we don't want to do that. Then what I like doing is consonants. It has S, P, R, K, and L. And then vowels, it has A and E. To help myself out, I sometimes break it up. And the reason why I break it up is this one's going to talk about consonants and vowels, so that's what I want to break it up. Once again, I still have 5 plus 2, 7. So I know I didn't miss one, right? Now here it says the vowels can be together. It should say must be together. That's like a typo, not can be. Then they cannot be as well. It should be must be together. So there's 7. 1, 2, 3, 4, 5, 6, 7. Now you have to read. This one says using all the letters in the word sparkle. Before I've said use 4 letters, right? 5 letters. So we have to read. This one's all letters, so I'm going to have 7 blanks. If it's 4 letters, I'd have 4 blanks, right? Now this one says the vowels must be together. There's 2 vowels. I hook them together. I get 2 options, then 1. Then I have how many letters left? 5, 4, 3, 2, 1. If it said vowels together at the front, I'd be done, 240. But it doesn't say vowels together at the front. It says vowels together. So how many more ways do I have to move it? 6. It's always 1 more than the number not attached, times 6. If you don't believe me, you can count. 1 way. Oops, 2 ways. 3 ways. 4, 5, 6. So this is going to be 2. 2 times 1 is 2 factorial, or just 2, because 2 times 1 is 2. And then 6, 5, 4, 3, 2, 1, blast off, 6 factorial, which could be just the answer on a multiple choice, or it's 1440. Now here it says it can start. Why do I have can? Why did I do that? Must start with a consonant and end in a vowel. 1, 2, 3, 4, 5, 6, 7. Only rules it has to start in a consonant, end in a vowel. How many consonant options do I have? 5. How many vowel options? 2. How many letters have I now placed? How many letters have I placed? 2. 1 in the first blank, 1 in the second blank, right? Do I have any restrictions on the 5 in the middle? No. So how many options do I have for this blank here? 5 letters, then I leave 1 behind. 4, then I leave 1 behind. 3, then I leave 1 behind. 2, then I leave 1 behind. 1. So this here, if you look at it, is 5 factorial, right? So they could write it as 5 factorial times 5 times 2, or what's 5 times 2? 10. So they might write 5 factorial times 10, or 10 times 5 factorial, or they might just give you the answer, which is 1200, I believe. Then we're going to flip over. So here it says answer the best questions based questions based on the Venn diagram. How many students like handball or swimming or badminton? Or is what shape? The snowman. This is an aggressive snowman. It's like a free circle snowman. It's a snowman with a growth. Okay, so we're going to add up everything inside the circles. What does that equal? 14, 15, 18, 20, 12, 4, and 8. 50, 65, 79, 83, 91. How many students only like swimming? So I go to swimming and I'm like, they can't like anything else. So how many like only swimming? 15. Right here. These other ones like swimming, but they like other things, which they're not allowed to like. For this question. How many students like both handball and badminton, but not swimming? Handball and badminton is an eyeball, correct? But not swimming. So I cover up the 12. And how many is it? 20. How many like handball or swimming? Or is what shape? The snowman. So handball or swimming snowman is this, which is technically 91 minus 8, which is 83. How many students like handball and swimming? Handball and swimming. And is the what shape? The eyeball. Handball and swimming. Does it say but not badminton? No, it just says handball and swimming. So I include these ones too, right? Which is 30. How many students do not like both swimming and badminton? Do not like both swimming and badminton. Swimming and badminton is those 16. So I actually have to not include those, and I have to include everything else plus the 16 out here, right? Which should be 91. Because I just took the 16 off of here and added the 16 back in. So 91. How many students only liked badminton? So I go badminton and I say I can only like it. 8. It says only like badminton. How many students like swimming or badminton? Snowman. Swimming or badminton? Snowman. So 91 minus 10 is 81 minus 4 is 70. Yeah. How many people like both swimming and badminton? Swimming and badminton. Eyeball. How many is that? 16. Then this one says, how many students like handball or badminton but not swimming. Handball or badminton, which is a snowman. And then but not swimming. Oh, can't count that, can't count that, can't count that. Right? So it'd be 20, 34, 42. Okay, you can put that away, and then we're going to open up our notes. Here it says, consider the stuffies example from last lesson. There were 6 ways to arrange the stuffies. We had 3 different stuffies. We had a kitten, a bunny, and a puppy, right? And then we just rearranged them, and we had 6 different ways. What would happen if instead of having 3 different stuffies, we had 2 of the exact same kitten and then 1 puppy? How would that affect your answer of 6? So let's see. Now we have 2 kittens. They look exactly the same, and a puppy. Correct? So we could go kitten, kitten, puppy. Right? Or we could go flip-flop the kittens. Kitten, kitten, puppy. Uh-oh. I flip-flop the kittens, but can you tell I flip-flop the kittens? No, because they look exactly the same, don't they? So this 2 cases normally would only be 1 case now. Okay, let's keep going. Then we could go kitten, puppy, kitten. Or we could go kitten, puppy, kitten. I switched the kittens. Can you tell the difference? No. So there's 2 cases that would normally be there, would be 1 case. And then I could go puppy, kitten, kitten. Or puppy and then flip the kittens. Oh no, doesn't look any different, does it? So this would be 1 case. So now instead of having 6 cases, how many would I have? 3 cases. Now, there's got to be a better way than listing them and saying, oh no, these look the same, right? Because this isn't too bad when it's 6 cases, but what if I had 10 cars and then I had 2 that looked exactly the same? That would not be the fastest way, right? It would be to draw them all out. You're probably going to miss 1 or 2. So what we do when there's repetition is very, very easy. Watch. We treat it, the top, like they're all different. So I do it like normal. So how many, I have 3 blanks to put stuffies, correct? How many stuffy options would I have for the first blank? 3. Then 2, then 1. So I do it exactly the same as if they're all different. Do you see that? Exactly the same as if they're all different. But they're not. How many of them are the same? 2. So all you do is you do the top like they're all different, and then you divide by factorial the doubles or triples or whatever. So how many do we have the same? 2. So we're going to divide 2 factorial in the bottom, and that gets rid of all the cases where they actually look the same. So all the cases where they look the same are now gone, just by doing 2 factorial. If, I'll deal with that in a second. So this would get me 6 over 2, which is 3, the exact same answer. Correct? So I'm going to do it up here above. What if there happened to be 6 stuffies instead? There were 6 stuffies. And 2 are kittens, the exact same. And 2 are puppies, the exact same. Okay? 2 are kittens, the exact same. 2 are puppies, the exact same. We agree? So we treat the top like all 6 stuffies are different. So how many blanks would I have? 1, 2, 3, 4, 5, 6. Why would I have 6? Because I'm still arranging 6 stuffies, right? How many stuffy options would I have for the first blank? 6. Then. So I actually have 720 different options of rearranging the stuffies. Hit 6 times 5 times 4 times 3 times 2 times 1 is 720. The problem is 2 kittens look exactly the same. So there's going to be cases where I swap them, but you can't tell. And 2 puppies look exactly the same. There's going to be cases where I swap them and you can't tell. So last time we divided by 2 factorial for the 2 kittens, correct? We are not going to divide by 4 factorial because that would mean I have 4 that are exactly the same. Do I have 4 that are exactly the same? No, I have 2 that are the same and 2 more that are the same. Correct? So on the bottom, and I'm going to put this in brackets because if you don't put it in brackets, you're going to get it wrong every time. 2 factorial, 2 factorial. So I'm actually dividing by 4. Now everyone try this out in your calculator. Try this in your calculator. Pull out a calculator and say I have 6 factorial over 2 factorial, 2 factorial. Just type it in how you would. Just go 6 factorial divided by 2 factorial, 2 factorial. 720 divided by 4 is actually 180. But you do that. You go 6 factorial divided by 2 factorial, 2 factorial. You're going to get 720, aren't you? Because remember, your calculator does BEDMAS. Your calculator does BEDMAS, so you're going to be wrong. Your calculator is going to go 720 divided by 2 factorial, so divide by 2 factorial gets me 360, and then it's going to take that answer and it's going to multiply it by 2. Is that what I want it to do? So if you type it in just like this, it's going to do order of operations. It's going to do this, and then it's going to times it by 2 factorial, which gets you a wrong answer. What do I want it to do? 6 factorial divided by 2 factorial, 2 factorial. So now type it in with brackets, because that's what you actually want it to do. So go 6 factorial divided by 2 factorial, 2 factorial. Now if you have the fancy new calculators, what's your way around this always? The fraction button. Just go alpha y equals enter, right? And the fraction button pops up. And then we don't care about brackets. If you have the older calculators, you have to do brackets. You don't have the option of getting the fraction button. But if you have the fraction button, alpha y equals enter, you'll never make a mistake because it's going to put it into the denominator, right? So it's up to you how you do it. You're doing your calculator, you do you. But if you have the new ones, the way to not make mistakes is to make sure you put in the fraction button. So here we have example 1. In the mountainous region of India, China, these questions crack me up. In the mountainous regions of India, China, Nepal, and Bhutan, right? Those mountainous regions. It is common to see prayer flags, just so you know. Fun fact Monday. Each flag has a prayer written on it. I learned so much actually through these weird things. And color is used to symbolize different elements. Green is water, which makes no sense to me, but okay. Yellow is earth, white is air and wind, and blue is sky space. I guess they can't do water with blue because blue is sky space, so I guess they had to go. It makes sense with the next closest. And red is fire. Now, how many different arrangements of the same prayer can you make using all 9 flags? So we have to use 9 flags. How many blanks are we going to do at the very least? 9. We know that, right? So we use all 9 flags. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then it says there's 1 green, 1 yellow, 2 white. Can I tell the difference between these 2 white? No. Boom. 2 factorial. Thank you. And then 3 blue. 3 factorial as well. And then 2 red. 2 factorial. Do you see how I don't even read the rest of the question? At this point I can put those in so I don't forget them. Because if you don't do them right away when you're reading it, to know that they're the same flags, stuff like that, often people will forget it. And they'll always have the answer with you forgetting the factorials on the bottom. So they'll have the answer correct with the factorials missing, and then the answer correct with the factorials in, which is the actual correct answer. Okay? Now, is there any restrictions on like the first part of the flag has to be white, the last part has to be blue, and the middle one has to be green or anything like that? No. There's no restrictions, is there? So I go to the top and I say, how many different colors can I have for this blank? No restrictions. How many different colors? How many colors are there? Nope. 1, 2, 3, 4, 5, 6, 7, 8. Where the heck is the 9th one? 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's add them up correctly, Lepp. There's 9 flags, is there not? Do I care that they double or triple up? No, I got rid of that on the bottom, correct? Remember, the top is as if they're all different colors, correct? That you could tell the difference between them. So how many flag options do I have for the first blank? 9, then, 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 then. So on the top I have 9 factorial over 2 factorial, 3 factorial, 2 factorial, in brackets if you're not using the fraction button. Type it in. Practice, practice, practice. Practice, practice, practice. And everyone's practicing it because you want to know how many times people will have the right answer like that and the wrong answer below it. Like, you'll have the work right, and then you get the wrong answer on your calculator. Bryden, what did you get?
30?
A little low. Oh, that'll get you. That 6 factorial. Knock it down. Okay. Really? 120? Okay. Sorry, I trailed off after the. You said 15,000 really loud and then trailed. Yeah. Boom. Do we agree? Yes. Okay. If you did not get that, talk to someone beside you. You probably have the wrong number in, or you didn't bracket it. Okay? So here it kind of sums it up. The number of permutations of n objects for A are the same of one type, B, it looks like bear, there's supposed to be a space, B are the same of another type, and C are the same of yet another type, can be represented by n factorial over A, B, C factorials each. Now remember, the top, we treat them like they're all different. Like I can tell the difference between the 3 blue cars, even though they're the same model. Remember how I said different model doesn't matter if they're the same blue, because I can tell the difference, right? But if they're the same model, they're all 4 focuses in this very same blue. If I line them up and then move them, you can't tell the difference. Now some people are like, I sure could. Well, let's pretend you can't. You're not like an investigator of blue Ford Focuses or something. What is going on, Simon? ADD was strong for a second there. Okay. Example 2. What is different with this example right now than all the examples we've done before? There's repeating letters. So, there was a kid that I used to tutor back in the day from a different school in our town. And you can figure out what school it is. I just don't want to list it because we're podcasting, and I don't want you to shout it because we're podcasting. But there was another school in town, and I was helping the kid tutor. And they had teacher had a genius idea. So what they got the kid to do, and I'm giving them credit because it wasn't me, I just use it, is that they got the kids to always rewrite the word out and stack letters so that A, you don't miss any letters of doubles or triples, and B, which I'm showing 2, I don't know why, B, if you're stacking them, it might be like, oh wait, I have to divide by factorials because they're the same. It might give you like your brain a jolt of remembering to divide. So what they did is they went V, and then an A doesn't match, so I write it beside, then an N doesn't match, so I write it beside, then a C, then an O, then a U. Now I get a matchup letter, a B, so I'm going to stack it. Do you see that? And then an E, and then an R. So stacking it does 2 things. It reminds me, hey, there's 2 B's. And also it reminds me that it doesn't matter what the question's going to ask, I'm putting 2 factorial on the bottom of this baby. So I immediately just write it on the bottom. Do you see how I don't even care what the question is? I just put 2 factorial. Now for these questions, they have to ask you to do the whole word. So it'll always be, when there's doubling and tripling letters, it always has to be the whole word. Or else you won't know if you used it or not. Okay, so how many letters are in Vancouver? 9. And we always double count, because we don't want to miss one. So there's 9. So how many blanks do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9. You're right. Now does it say I have to start with a V, or end with a vowel, or start with an M, or hold the vowels together? Any restrictions on it yet? Nope. So how many letter options do I have for the first blank? 9. Then? 8, then 6, then 5, then 4, then 10. So I'm going to get 9 factorial over 2 factorial, 2 factorial. Because I'm still playing with the last question in my head. It's only one of them. Now, if you have just one number on the bottom, like 2 factorial, and you forget brackets, does it hurt you? No. It's only if there's 2, but I just always do brackets if you're someone with an older calculator, just so that you never forget them. I don't know what is going on, but it's scaring me. All right. What is the answer? Does someone have it? 725,760?
Oh, man. You messed up again?
Disagreement. Okay. What?
I have to divide it.
So that was the answer. Divided by 2 is? Nope. Then it wasn't at all. Something is wrong. 181. 740? 440? McLemon, something was real off. This is.
Now I divided it.
Okay, do mathematical. Go. See, to me, it was genius that the person came up with this idea. I was like, I like this idea. It's nice to learn much. So, mathematical has how many letters? 12. Do I have to go 12 blanks, then go 12 times 11 times 10 times 9 times 8, or could you just go 12 factorial, knowing that we now know that? We're going to do that. And then on the bottom, we're going to have 2 factorial for the n's, 3 factorial for the a's, 2 factorial for the t's. Do not put 7 factorial. That would mean that you have 7 of the same letter. Do we have 7 of the same letter? No, we have 2 of one, 3 of the other, 2 of the other. Do not sum them all together, okay? That will result in bad things. And it will result in a correct answer, because that's also a common error. All right. Correct answer on, or sorry, not correct answer. It will result in an answer on the test, which will be wrong if you do put them all together. So what's the answer for this one? Try again, just say the numbers.
1, 9, either 4 or 9, I can't really tell. 9, okay, 9, 5, 8, 4, 0, 0. 5, 8,
You can't read your own writing. What chance do I have? Excellent. You can't read your notes either. All right. So 3 says the word answer. Does answer have any doubling or tripling letters? A-N-S-W-E-R. So if we want to, we can go A-N-S-W-E-R. If you literally just rewrite the word, there are no doubling or tripling letters, right? So my denominators, yep.
That you wrote down.
What did you guys, I'm missing a 9?
It's supposed to be 19,958,400.
I told you it was either 9 or 5, you didn't list it.
No,
You said 9 or 5.
no, you were just missing a 9. 5,
It's
8.
there, she said written wrong. Yeah, she said put it in. She said 19, and then 9 or 4. Yeah. And I said 9. 5, 8, 4, 9.
Oh my gosh. All right. Not asking you two for answers for right now. We're going to give you guys a little break ski, and then we'll come back to you. See if we get it back.
I'm so sad.
There you go. So without restrictions, how many letters are there? And it says arrangements of 6 letters. 1, 2, 3, 4, 5, 6. So this would be 6 times 5 times 4 times 3 times 2 times 1, which is 6 factorial, which is 720. Now this one says begins with an S. 1, 2, 3, 4, 5, 6. This has to be an S. How many options? Not trickery. How many options of S's? 1. Then I set a letter down. How many do I have for the next blank? 5. Then. So it's actually 5 factorial, which is 120. You could go 5 factorial times 1. But it's still 120. I didn't have to divide by anything because answer has no doubling, tripling letters, right? Then flip over. Now it says begins with a vowel and ends with a consonant. Begins with a vowel, ends in a consonant. A-N-S-W-E-R. How many are vowels? 2. How many are consonants? Which is 4. How many letters have I sat down? 2. How many do I have left? 4, then 3, then 2, then 1. So you could just type it all in at once, or you can go 4 times 3 times 2 times 1 is 4 factorial, and then 2 times 4 is 8. So it's 4 factorial times 8, which is some number. Or you can go 2 times 4 times 3 times 2 times 1 times 4. What do we get? 192. Seems realistic because it'd be 24 times 8. So, next one says that have 3 letters A, N, and S adjacent. Adjacent means what? Together, side by side. That's what adjacent means. Because they use adjacent. And it has to be in the order, this is important. It has to be in the order A, N, S. So we have 1, 2, 3, 4, 5, 6 hooked together. Now normally it's 3, 2, 1, but not this time. How many is it going to be? I have to have A, N, S in that order. How many A's? How many N's? 1. How many S's? 1. How many letters have I sat? 3. How many do I have left? 3, then? What? The 8? 2 times 4. Because I can write it as 8. So this is 4, 3, 2, 1, which is 4 factorial. They're all multiplied, right? They all have multiplication symbols, we agree? McLevin, you're giving me a look like you don't... This is a multiplication symbol. Okay. Yeah, you have to say yes, because you're just giving me a weird look and I don't know what you understand. So what? So 4 times 3 times 2 times 1 is 4 factorial, and then the numbers you have left are 2 and 4, and what symbols are between them? Multiplication. What's 2 times 4?
What are you trying to figure out in this question?
The answer, but you can write it as 4 factorial times 8 as a multiple choice answer, because it's 4 factorial, and 2 times 4 is 8. This is 4 factorial times 8.
Is that how many ways we can write it with a vowel in front and a
Yes.
consonant in the back?
Yep, because that's what it asked for. And then I gave an answer. It's crazy. So the answer matched the question. It's rough. Yeah. Is that the answer to the question? I think so.
Okay. I was like, okay, makes sense. I see the 8. Hold up.
It's just 4 times 2. Okay.
So nice.
What's the problem with D that I haven't done yet?
Not a clue.
You haven't times it by 4.
I haven't times it by 4 because it doesn't say adjacent in that order in the front. It says adjacent, so they have to be together. And then I can move them 1, 2, 3, 4. It's always one more than the number after the hook together numbers. So now I can go 4 times 3 times 2 times 1, which is 4 factorial. And then technically I could go 1 times 1 times 1, which is
Oh, so that's
1.
like you did a
Light bulb.
top.
Yep. So I could write it, multiply it by 1, but that's kind of dumb. Well, it's not dumb. It is kind of dumb, but it's not going to be written in a multiple choice answer times 1, right? Because anything times 1 is just itself. So they would write it as 4 factorial, or they would write it as 24. E says that have the 3 letters A and S adjacent, so they have to be together, side by side, but not necessarily in the order A and S. It could be in any order, right? It doesn't have to be in the order A and S. So what's the only thing that changes? These are hooked together, but how many options do I have for the first blank now? 3. Then the second blank. Then the third blank. Because A and S have to be together, but they don't have to be necessarily in the order A and S. Then how many do I have left? 3, 2, 1, and then I have to multiply it by 4, because it's going to move here one way, 2, 3, 4, or always one more than the number after they're hooked together. Now, if I go 3, 2, 1, what do I get? It's going to be a really large number, because it's really thick. 3 factorial, and then what is this? 3 factorial times 4, which is just 4 factorial. Because 4 times 3 times 2 times 1, blast off, it's the factorial symbol. Which is what? Now, what's different between example 4 and example 3? I don't care that it's not a real word. I just need to make some letters double. Answia. There are actually what? There's repetition. There's 2 A's. So if I go to stack these babies, I'm going to get A, N, S, W, E, A. So every single question is going to have what happen? Dividing by 2 factorial. So without restrictions means I don't care where the letters are, correct? So how many letters would I have? 1, 2, 3, 4, 5, 6. That hasn't changed. How many letters do I have for this blank? 6. Then I leave one and it's 5. Then I leave one and it's 4, 3, 2, 1. Remember, I don't care that the A's are the same. I treat them like they're different because the 2 factorial gets rid of the fact that they look the same. So last answer would have been 720. This one's 720 divided by 2, which is 360, which makes sense that half of the answers would go away because when you have AA and then you flip the AA, the second case would go away every single time because you can't tell the difference. Now B says it has to begin with an S. I don't care that it has to begin with an S. I'm immediately going to go 2 factorial on the bottom because I have 2 A's. I don't overthink it. Then I have 1, 2, 3, 4, 5, 6 letters. What's the first blank going to have to be? 1 because it's an S. And then I left 1 letter behind, correct? So how many do I have left for the rest that don't have any restrictions? 5, then 4, 3, 2, 1. And 1 times 5, 4, 3, 2, 1 is just 5 factorial times 1, or just 5 factorial over 2 factorial.
It's 1 more than the other number.
We're not holding anything together.
Oh.
So it's 60. Yeah. When you have to have things together, because then they can move into different spots.
Oh, right, yeah.
Yeah. Begins with a vowel and ends with a consonant. 2 factorial is going to be on the bottom. It's the only. Now it has to begin with a vowel. The catch this time is how many vowels are there?
2.
There are not 2.
There's 3.
There's 3.
Combine the A's and
But we don't do that, right? We treat them like they're different because the 2 factorial gets rid of all the cases where they're the same. And then consonants, how many consonants are there? 3. Now I've sat down how many letters? 2. So how many do I have left? 4 then, 3 then, 2 then, 1, and then this can blow people's minds. So I'm going to have 2 factorial on the bottom,
4 factorial on top.
4 factorial on the top times,
And then 3 by 3. So 9. No, what?
yes.
Yes.
Went from lost to completely with us again. See?
You're welcome.
So what do we get for an answer?
I've done it, so.
Remember, the top has to go in brackets too if you have more than one number. 108. So these, if you have the option of a fraction button, it's substantially better if you use it, because if not, you have to put your top in brackets, bottom in brackets, unless they only have one number. Now here it says that have 3 letters A, N, S in the order A, N, S. So I'm going to go 2 factorial on the bottom, Then I need to have it in the order A and S, which people tell me is 1, 1, 1. That's not true though. It's 2 because you have 2 A's. This has to be an A, this has to be an N, this has to be an S. How many N's? 1. How many S's? 1. Now I know you can't tell the A's apart, but the 2 factorial gets rid of those cases, right? So we treat them like you can tell them apart. And how many letters are left? 2, 1. Now it says they have to be adjacent and in that order, but does it say they have to be at the front? No, so I have to multiply by 4. No, I multiply by 4. The 4 joining the 3, 2, 1 makes a 4 exclamation mark. This is not a 4 exclamation mark. It's just a 4. But 2 times 1 times 1 is 2. We don't have to do that though.
What? Where does that come in then?
Well, 2 is 2 exclamation mark. They're the same answer. Because it's 2 times 1, right? And then 4 times 3 times 2 times 1 gets you the 4 factorial over 2, which is 24. You can, as long as you're not trying to match a factorial symbol multiple choice. Also, you could be matching a factorial symbol numeric response. So that's why I do the factorial each time, because you might have to match them.
And it'll say like that.
Yeah. Well, you'll either see it as an answer in the numeric response, or it'll be a multiple choice answer. If it was a multiple choice answer, you could turn it into an answer, turn yours into an answer, and match them as well. Okay?